The dark wonders of the cosmos. Space is more unpredictable than we dare to dream. In the vast reaches of the universe, forces beyond comprehension shape the stars, sculpt galaxies, and sometimes threaten entire worlds. Picture this: a colossal wave of energy rips through space, invisible until it strikes. It's not a weapon forged by human hands, but a natural cataclysm born in the hearts of dying stars. This is a neutrino storm, a barrage of ghostly particles unleashed when a massive star collapses into a black hole. If one passes too close to Earth, it could silently disrupt the delicate chemistry of life itself. Most of us go about our days unaware of the lurking dangers beyond our atmosphere. Imagine a star, dozens of times larger than our sun, reaching the end of its life in a nearby corner of the Milky Way. As it dies, it doesn't fade quietly. It erupts in a supernova so intense that its light outshines entire galaxies for a fleeting moment. The blast sends shockwaves and radiation racing toward us. If it's close enough, say within 50 light years, the flood of cosmic rays could strip away our ozone layer, leaving Earth vulnerable to the sun's unfiltered wrath. Temperatures would soar, storms would rage, and life as we know it could wither under the assault. These supernovae are among the most violent events in the universe, second only to the Big Bang itself. They release as much energy in a few seconds as our sun will emit over its entire 10 billion-year lifetime. Their brilliance is staggering, visible across billions of light years, a testament to their raw power. Scientists believe these explosions have already extinguished countless civilizations across the cosmos, snuffed out before they could ever reach out to us. Back in 1987, astronomers witnessed a supernova in the Large Magellanic Cloud, a neighboring galaxy just 168,000 light-years away. Named SN 1987A, it was the closest stellar explosion observed in centuries. At first, telescopes caught only a faint glimmer, but then it blazed into view, revealing the death throes of a star 20 times the mass of our sun. The neutrinos it unleashed reached Earth hours before the light, a chilling preview of its destructive potential. If it had been closer, the consequences might have been dire. Studies of its aftermath showed how these events forged the heavy elements, gold, silver, uranium, that make up our world. A reminder that creation and destruction are two sides of the same coin. But supernovae aren't the only threats lurking. The void. Consider the Magnetar, a type of neutron star with a magnetic field 1 trillion times stronger than Earth's. These cosmic beasts are born from supernova remnants, their cores crushed into a sphere just a few miles across, yet denser than anything we can imagine. Every so often, a Magnetar's magnetic field twists and snaps, unleashing a flare of gamma rays and X-rays. In 2004, one such flare from a Magnetar 50,000 light-years away briefly lit up Earth's upper atmosphere, detectable even from halfway across the galaxy. If a Magnetar flare erupted within 10 light-years, it could fry satellites, disrupt power grids, and bombard the surface with lethal radiation. Why do these events happen? Magnetars form when a massive star's core collapses. Spinning so fast it amplifies its magnetic field to unimaginable strength. The energy released in a flare rivals a supernova's, but it's focused into a narrow beam. Only a fraction of these beams ever point our way, which is why we don't see them daily. Still, the odds aren't zero. A strike within 100 light-years could deliver a dose of radiation 1,000 times the lethal limit, turning a quiet day into an apocalypse with no warning. Now, shift your gaze to something closer to home: the asteroid belt, a ring of rocky debris between Mars and Jupiter. Most of these space rocks drift harmlessly, locked in their orbits. But every so often, a gravitational nudge, perhaps from Jupiter's massive pull, sends one hurtling toward Earth. Take the Chelyabinsk meteor of 2013. A 60-foot-wide boulder entered the atmosphere over Russia, exploding with the force of 500 kilotons of TNT, 30 times the Hiroshima bomb. Windows shattered, buildings shook, and over 1,000 people were injured by the blast wave. It was a small object, yet its impact was felt across a continent. Now imagine a rock a mile wide. One struck Arizona 50,000 years ago, carving out Meteor Crater. A mile-wide scar still visible today. A larger one, 6 miles across, hit the Gulf of Mexico 66 million years ago, triggering the extinction of the dinosaurs with a force equivalent to 10 billion atomic bombs. These near-Earth objects, or NEOs, are tracked tirelessly by NASA and other space agencies. Over 30,000 have been cataloged, with more discovered each year. Most will miss us, but the risk remains. In 2038, an asteroid named 99942 Apophis will skim past Earth, closer than our geostationary satellites. Its odds of impact are slim, less than 1 in 150,000. But if it threads a precise gravitational keyhole, it could return in 2045 to strike with the power of 1,200 megatons, dwarfing any nuclear arsenal. Scientists are already devising plans. Deflect it with a kinetic impactor, or nudge it off course with a gravity tractor. The technology exists, but time is the wild card. Beyond asteroids, the Sun itself harbors a hidden menace. Solar flares and coronal mass ejections, CMEs, erupt from its surface, hurling charged particles across the solar system. In 2012, a CME narrowly missed Earth, packing enough punch to rival the Carrington event of 1859. That earlier storm lit up skies with auroras visible as far south as the Caribbean and fried telegraph lines with induced currents. Today, a similar event could cripple power grids, knock out satellites, and plunge cities into darkness for weeks. The Sun's 11-year cycle brings peaks of activity, and with each one, we roll the dice. The next big CME could cost trillions in damages, a reminder that even our life-giving star can turn against us. And then there's the ultimate enigma, dark energy, the mysterious force accelerating the universe's expansion. Discovered in 1998, it's pushing galaxies apart faster every moment. In billions of years, it could stretch space so thin that distant galaxies vanish from view, leaving the Milky Way isolated in a cold, empty cosmos. Stars will burn out, black holes will evaporate, and entropy will claim everything. It's not a threat we'll face tomorrow, but it's the inevitable fate of all we know, a slow, silent unraveling of the universe itself. Earth sits in a precarious, deep spot, a fragile oasis amid these cosmic titans. We've survived eons of bombardment and radiation, yet the threats persist. The KT impactor that ended the dinosaurs paved the way for mammals, and us, to rise. But the same forces that shaped our past could erase our future. Look up at the night sky. It's beautiful, yes, but it's also a gallery of potential disasters. Astronomers watch tirelessly, mapping NEOs, monitoring the sun, and peering into the depths of space. The James Webb Space Telescope, launched in 2021, now scans the heavens, revealing ancient galaxies and stellar nurseries where new threats might one day form. Meanwhile, missions like DART, which successfully redirected an asteroid in 2022, prove we're not helpless. We can push back against the cosmos if we act in time. So what do you think? Are we lucky to have dodged these bullets so far? Or is our number just waiting to come up? Earth spins on, a sapphire speck in a universe that's equal parts wonder and terror. Our daily routines hum along, but out there, the wild ride continues, unpredictable, unstoppable, and utterly breathtaking. If you're fascinated by the mysteries of space, stick around. The universe has more secrets to share, and we're just getting started.